set. So our next presenter, let me introduce you, is Ms. Sara Collins. She is a product marketing specialist for commercial rooftop units at Lennox Industries, a leading heating, ventilation, and air conditioning manufacturer. She is responsible for monitoring industry trends and providing recommendations for new product development. Prior to joining Lennox Industries, Ms. Collins was a systems engineer at HVAC Systems. Ms. Collins holds a mechanical engineering degree with a concentration in HVAC from UT El Paso. She is currently pursuing a master's in engineering management from SMU Lyle Graduate School of Engineering. Please help me welcome Ms. Sara Collins.
All right, can you hear me? No? Yes? In the back? Yeah? Okay. Well, good morning, everyone. I'm excited to be here. It's a great opportunity for us to talk a little bit about solar energy applications for HVAC systems. And today we're going to focus a little bit on a practical application of on-site renewable energy, which helps buildings qualify for LEED credits. So before I begin, I do want to introduce Donna Peoples. Donna, if you could please stand up. Donna has been with Lennox for over 38 years, and she's a regional K-12 manager for commercial rooftop units. At the end of the presentation, we're going to walk through a little demonstration of a solar panel that we brought here. She's going to be helping me to identify some of the key elements of the solar panel. So let's get started. This is the agenda for today, and first we're going to go over a high-level overview of how photovoltaic systems work and which are some of the components that make up a photovoltaic system or PV system. And then we're going to talk about the economic trends of the PV industry, as well as, there's a sustainable growth in the PV industry. So we're going to take a look at why there's a big growth or a big push for PV or solar systems. And then we're going to talk about traditional string inverter systems. And these systems are the most widely adopted systems, or the most popular, although there are several complications involved in the installation. So it's not a very practical solution for PV systems. So then we're going to go into and talk about the microinverter PV systems, which is a relatively new technology in the PV world, which is this system that actually allows the direct integration with HVAC. And then at the end, I'm going to cover a little one slide of how can buildings achieve points and how many points can they achieve based on the percentage of renewable energy produced. So how does photovoltaic system work? First, let's start with the word photovoltaic. And this is a combination of two words, which is photo and voltaic. Photo is Greek in origin, which means light, and voltaic comes from volt, right, which is one of the fathers of electricity, Alessandro Volta. So if you combine these two words, the significance of this word, it means conversion of light into electricity. So the way this works is a solar module is composed of multiple solar cells. And in the solar cell level is where all the magic happens. And if we take a look at the cross-sectional area of a cell, you can see that the cell is composed of two layers. The first layer is usually negatively charged. The second layer is positively charged. So what you have in the middle is an electromagnetic field. So when you have photons hitting on the panel or on the cell, there's an instability going on at the microscopic level. So then you have loose electrons that are capable of flowing through those metal conductor strips, which generate DC current or electricity. So a module is composed of multiple solar cells connected together. And then if you connect multiple solar modules together, you have an array. And arrays vary by size and configuration. So even if you have a 16-panel array, you can manage to accommodate the panels differently depending on the space of the available. So how does PV energy work? This is a schematic of traditional string inverters. And as you can see right here, the PV modules collect energy from the sun to generate DC current. The DC current is converted to AC current via string inverter, which is the red box right here. The current transformed by the inverter is then sent to your main distribution panel, which then powers the electrical devices in the building. Now, if a building does not use all the electrical produced by your panels, you can send that back into the grid for possible credits from the electric utilities. So, why the big push? If we take a look at the reasons why solar industry has gained so much popularity is because of all of the items listed here. We all know that energy is going up. The cost of energy is just increasing. And you probably saw in the news in the last couple of days of, all the concerns about the price of gasoline. How much are we going to pay during summer? Are we going to reach the $5 mark or not? There's also a big awareness on, regarding green. We've experienced a lot of natural disasters lately, and that's because we're starting to produce a lot of contaminant that it's causing an effect, right? So we're starting to take a look at a lot of degradation. So also utilities are experiencing a lot of demand and limited production capabilities. The United States has been really pushing for energy independence. Currently, we import a lot of oil from other countries. So we're trying to become a little bit more and more independent. Also, the technology has improved tremendously, and also it's becoming more reliable. If we take a look at this chart, we can see that over the past 10 days, we've seen a 50% reduction in the price of modules. If you can see, this is December of 2009 to March of 2011. So back in December of 2001, you can see that the price per watt was around $5.50, around $6. Now in March of last year, we can see that the price per watt went down tremendously. And you may think, the price per watt went down because there's no demand. But if we take a look at the PV industry, you can see that just from 2009 to 2010, the PV industry doubled. And actually the same happened from 2010 to 2011, where the PV industry also doubled. So this growth is expected to keep going. So now let's take a look at traditional string inverters. Again, these are the systems that are most widely adopted, although there are certain limitations associated with them. Number one is system efficiency. Traditional string inverters are connected in series. So what happens is you have multiple solar panels connected in series. So if one panel fails, the panels that are behind them are incapable of sending that current to your inverter. So what happens is that the efficiency of the entire system goes down. Reliability and design complexity. You need to design your system to where you have the exact number of panels in order to withstand the voltage and ampacity of your inverter and your distribution panel. And beyond that, the installation complexity is, you need to design your mounting system right up front. So later on, if you want to start with 1 or 2 panels, and later on you want to add 2 or 3 more, then you have to actually redesign the entire mounting system. And finally, safety. You have up to 600 volts running from your panels all the way to your inverter. So if we take a look at this is a schematic of a traditional string inverter. So if we take a look at how this system works, you can see that, again, the panels are on the roof. And in this case, we have 2 string inverters here. So these panels are connected in series, and they go down to the inverter. The inverter converts that DC current to AC current, and then it's sent to the main distribution panel to power the electrical devices. So again, what happens is that even if you have a DC disconnect at the street level, you still have a high DC voltage line running across the side of, or running across your building. So as long as there's sun, your panels are still generating current. So there is no way of keeping this part of your building safe. So now let's take a look at how microinverter systems work. Microinverter is a relatively new system, and the reason why I say relatively is because it was first introduced in the late 2000s, but it barely gained a lot of popularity because they've gone a long ways on improving the reliability and making it affordable. So the way this microinverter works is it's basically a miniature of a big inverter. So then you have 1 microinverter per solar module. So what happens is that since you have this microinverter right there, your DC current is converted instantaneously into AC current. So the biggest advantage of this microinverter is that you have AC current coming out of your panel. So you can power any device that you want. I mean, you can literally power the lamp or whatever if you plug it directly. And beyond that, there are multiple benefits associated with it. And even though it may have a first higher cost up front, that can be offset with the ease of installation. I mean, it requires less parts, less changes to your building, less changes to electrical infrastructure. So this is a kind of how it looks. Again, as you can see from the picture, the microinverter is located on the back of the panel, which converts your DC current into AC current. Now, the microinverters are connected to each other via a plug-and-play system, and I'll show it right here with the panel demonstration. So the electrical connections are relatively very, very easy to do. So let's pretend that you have 2 solar modules. So we have 1 microinverter that has a connection with a female end. Then you have the other microinverter which has a male connection. So you literally just plug them in, and that's it. I mean, the connections are done. Also, the other advantage is that it doesn't require changes to the electrical building infrastructure. And this is because the output of the microinverter can be used right away. And also, the output is not tied to the weakest panel. So if one panel fails, the other panels are still capable of generating current, of generating that electricity. And so therefore, the efficiency of your entire system doesn't go down. Another neat feature is that it has communication capability. So in a secure website, you're able to track the energy production of each solar panel, and it also shows the environmental impact that your system is causing. So these are some of the benefits of the microinverter. And we're going to go a little bit more in detail into each one of them. But overall, you have improved performance, increased reliability, it's easier to design, less complex installation, lower cost, more flexible and scalable and safer. So how do you integrate this microinverter system with HVAC systems? Integrating HVAC and PV systems or solar systems, it's a logical solution because power generation coincides with usage. So whenever your unit is running at full capacity, your solar modules are producing a lot of power because the sun is shining a lot. So also, there's a big real estate availability. I mean, the roof, it's basically like having a little power plant on your roof. Consuming power closest to the point of generation. Again, your solar modules are very close to your rooftop unit. So you're consuming right away. Rather than having, all the wiring, etc., you have a lot of losses by incorporating all the electrical wiring and changing the electrical infrastructure. Right here, this becomes a quick and efficient way of just connecting the panel directly to the unit. Now your HVAC unit not only becomes a point of consumption, it also becomes a point of power distribution. And this is because, as you can see from here, this is a schematic of how the microinverter PV system works with or integrates directly with the rooftop unit. And again, as you can see right here, the panels generate DC current. It's converted by the microinverter to AC current. It goes and powers a rooftop unit. Now, if your rooftop unit cycles off or is not working, that electricity is sent back to your main distribution panel via the existing power wiring. So this is very good because, you're literally using all the energy that you're producing. Nothing goes to waste. And also, not only that, but if your building, it's not consuming any energy, if all the appliances they're off, you can also send that electricity back to the grid, and this will entitle you for some credits from the electric utility. Right here I had a little schematic, but it didn't work. So now let's go into the benefits of of a microinverter PV system. Again, it's less complex and it's less cost. Again, with a microinverter, you avoid all the complexities of installing fuses, combiners, inverters, etc. It doesn't require changes to electrical infrastructure, so really the installation is relatively easy and quick. This is a comparison that one of the integrators from California made, and they determined they used to be a string inverter system company, but then they switched to the microinverter system. And they did this comparison, and they determined that it actually required 80% fewer parts to install this, and therefore it was the equivalent of a 20% less cost. Flexibility and scalability. Again, with a microinverter, you're not limited to the number of panels that you install. Of course, you're going to have, depending on what if you're connecting to an HVAC unit, depending on how the unit was designed, you may have a limit on how many panels you can install. But really, you can add as many panels as you want whenever you want. So that's the beauty of the plug-and-play system, where the electrical connections are very easy to do. So you can bring, if in the beginning of the project you only have a certain amount of money to buy 2 or 3 panels, you can always buy more and connect them. Also, it has a very straightforward design. It's more efficient. As I mentioned before, the system efficiency is not tied by the weakest panel. So if one panel fails, your other panels are still producing at the full speed, right? So the microinverter systems are 5 to 25% more efficient than traditional systems. More reliable and safer. Again, I mentioned this, and it's right there again. The failure of one panel does not bring down the system. And also, one of the nice features that a microinverter has is that it has a shut-off power safety mechanism, in which if it doesn't sense that your main distribution panel is sending current to your building, this means that if you turn on the breaker in your main distribution panel, your microinverters will immediately shut down. So this means that once you just need to turn something on and off, and the microinverters will also turn off. Financial benefits. There are a lot of benefits when you integrate a PV system with HVAC. You can gain up to 34 effective SEER efficiencies when you combine some panels with your HVAC unit. And also, your unit may be capable of achieving net zero status. This means that, again, if your unit is off or if your unit is in ventilation mode, your panels may be producing more energy than your unit is consuming. So therefore, your energy consumption and your energy production offset at 0. energy benefits, and it helps reduce dependence on the energy grid. So then you're not depending. So right here, you're actually capable of sending that current to a rooftop unit during peak load demands, and that helps you offset the demand charges. This is a screenshot of the monitoring website. As you can see right here, you can clearly see how much power each solar panel is producing. So if this panel is black, it means that there's something wrong with that panel. And you can go up there and see if there's, probably the microinverter is not connected correctly, or if there's something wrong with the panel. And also the nice feature about the website is that if there's a problem with your system, it's going to send you an email with an alert saying, hey, you need to go up there, you need to verify that your system is operating correctly. And also, as you can see right here on the top row, it tells you the power production of your system. You can see either the overall, that day to day, for the past 7 days, for the past month, and for the lifetime. It also graphically shows you how much production your system is having. So as you can see from here, from this chart, from 7 p.m. to 7 a.m., you're not producing any energy because the solar is down. The sun is down. But as the sun starts rising, you can see that the production of your solar panels start increasing. Also, as you can see down here, it tells you the environmental benefits up to date. So in here you can see, well, you're producing the amount of energy that it's equivalent to powering 99 light bulbs, 33 computers. It's equivalent of offsetting 1 tree, or planting 1 tree, or removing 3 gallons of gas. And last but not least, on-site renewable energy credit. This shows how many points schools can earn with having on-site renewable energy in their buildings. And again, it depends on the percentage of renewable energy produced. And this percentage is a contrast between how much you're producing versus how much your building is actually consuming. Also, I wanted to mention that ASHRAE 189.1 also calls for having on-site renewable energy systems. And right here it says, buildings shall provide for the installation of on-site renewable energy systems. So, in summary, integrating photovoltaic systems with HVAC systems can significantly provide energy savings by reducing operating costs and demand charges. It can reduce your dependence on the energy grid. It helps a rooftop unit achieve net zero energy status. It helps qualify for tax credits, for rebates, for grants. It demonstrates environmental stewardship, and you can reduce your building's carbon footprint. It helps buildings meet ASHRAE 189.1 as well as earn LEED credits. It's very simple to design, to install, and no changes to electrical infrastructure are required. It's more efficient and safer to operate than traditional solar systems. So right here we brought a panel which has a microinverter, and Donna, she's going to help me kind of demonstrate the components. And right here you can see that, well, whoa. Can you, yeah, you can.
They're not heavy, it's just hard for a short person to lift.
Hello? Oh.
Panels are only 47 pounds and you have no structure with them to your building. And this is your microinverter.
So, right, okay, here. No, go ahead.
They won't hear you.
Yeah, they don't hear you.
This is your microinverter right here. And it comes factory installed, everything is ready. When you decide to go with solar, you do a diagram how you're going to lay it out on the roof. The hardware, every little part and piece comes, and when you get it, you just hoist them to the roof and plug them in. That's how simple it is. You have a thing in your flyer of a school district in Arkansas. They were the first ones to install this type system. And 2 guys from the school district, HVAC guys, 1 electrician. From hoisting to turn on was 3.5 hours. So that tells you how easy it is.
Right. And actually, I had the opportunity to be there, and literally it was 3 guys and myself putting this together. It took us 4 hours to have it up and running. And right here, this is a microinverter, and as I mentioned before, you know, this part of the cable will go in and connect to the next microinverter. So if we would, you know, if this was the microinverter that was located next to it, you will have this connection here. So you would just bring in the female and male connections like that. And then you have your safety switch, your safety cap. So you twist it and that's it. So that's all that is required. Now, if you want to make sure that you're, how do you know if these are connected appropriately, right? Well, there is a little LED light right here on the bottom that tells you if it's flashing green, it means that it's operating, that the panels are producing energy. If it's red, it means that you did something wrong here. Yeah. And again, the reason why this is so easy to install is because, it's not only a panel. It comes with a microinverter. It's a panel, but it's also this framing. And you can come and take a look a little bit closer on how the frame is. But on the side, you have threaded holes. So the way you connect 2 panels together is, you bring another panel here, and we call it a splice, which is basically a rod that is threaded in opposite directions. So what you do is that you bring that rod, you give it a twist, you bring the other panel, and with the wrench, you start twisting it until both panels come together. What else? Questions? Yes.
What kind of heat can the inverter take?
I'm not sure.
Some roofs get really hot.
Right.
Like
Right. And I know they're UTL tested and all that, and probably right here I can look at.
The wiring and the inverters and everything is still are built with the heat shield like they use in space. So it takes several thousand degrees.
But that's also for the primary component, the inverter as well.
Yeah, and,
Right.
and everything that connects.
What's the lifespan on that solar panel?
It has a guarantee for 25 years at operating at 80%.
What's the cost on
The cost depends if you buy it direct through a contractor, general contractor, all that. But for a rule of thumb, on cost, I always tell everybody figure $1,000 a panel. That's all your hardware, everything that you would need, your monitoring device that you would put inside. And that's a rough estimate. You can buy panels for $600, but then you have to buy all the parts and pieces and put them together. This technology's only been out, it was announced
Last year.
February of 2011. It's caught on pretty quick. The secret to the whole thing is when you go to replace a rooftop unit, you have to order it solar ready because it's not retrofittable in the field because of all the UL, ETO, and all the approvals. So you say, well, okay, if you got to replace a rooftop unit anyway, for you to make it solar ready, any idea how much it's going to cost you?
Guess? No?
No guesses, huh? If the voltage is 208, 230 volt, single phase or 3-phase of your rooftop unit, it's under $200. So it's not a real high dollar ad. And then, of course, with our current administration wanting everybody to use renewable energy, there are a lot of places that you can go out and get grant money to pay for them. EPA, every little bit, puts out grants at $15,000 per city or $15,000 per school district or whatever. $15,000 if you're doing the installation yourself goes a long way to making that unit net zero. If it doesn't make it net zero, it depends on the size of the unit. So you just have to be ready. It doesn't matter if you don't add panels for 5 years. If the unit's ready, then you can do it. You can add 1 panel, 2 panels at a time. So as the grants and all the freebies come available, you can do it at that time.
How much of power does the panel distribute per panel?
This panel, currently we offer the 190 watt panel. So it's 190 watts
You can go get 235 also.
later on
Yeah.
this year. Now we do have it available in single and 3-phase, so it depends on what.
How are you backfeeding the power to the existing electrical?
Panel
backfeeding
distribution.
The power from this to the existing electrical system?
Well, the electrical connections are done to the rooftop unit. But what happens is that the output of the microinverter is at a slightly higher potential or voltage than the existing or the utility power. So what happens is that if the microinverter is producing current and you want to backfeed it to the grid, it's going to flow back. So it's like having 2 hoses in one, 2 outputs in one, 2 inputs in one output, right? If this is a higher potential, this is going to go first. So that's the reason why you don't need to change the electrical infrastructure, because by the connections of the HVAC unit to your panel, it flows down. Right. So when it's off, yeah, correct. Yeah, go ahead.
What are the safeties to prevent injuries in the event that the city drops your power and you're still feeding more power on the line?
What are the safety features?
Feedback in the event the city shuts your power down.
Okay. So what happens is that your microinverter is not going to turn on unless it senses the main distribution panel frequency. So what happens is this microinverter syncs with the frequency of the electrical utility power. So unless it senses that and synchronizes with that, then it's going to produce power. Otherwise, it's just going to shut down. That's the reason why this is a grid-tied system, meaning that it's connected to your utility grid.
Through your HVAC unit.
Through your HVAC unit, correct.
How resistant to damage are those units? We get a lot of hail in Texas.
Yeah, we've had that question a lot, and actually down in, up in PD&R in our research and facility location, they've tested these panels, and they've actually shoot golf-sized balls of hail at 160 miles per hour. So it's,
With no damage.
right. Right. This is basically the material that they use here is like what they use on the cars, the windshield glass. So, when you have hail, your cars don't get damaged. Well, the glass doesn't break, so it's kind of the same material here.
Kind of a follow-up question to that. How is the building owner approaches insurance company to insure these panels? How are have you gotten any feedback on how the insurance companies are looking at these?
No, do you know, Donna?
Charging additional premiums or that sort of thing?
I don't know. No one's ever
No.
told.
Yeah, we've had situations where they do the insurance of the building. They do have concerns because of the weight and stuff like that. But as long as you meet the weight requirements, you're pretty much okay. I don't know if that helps or not, but kind of.
Not really the weight requirements, it's more,
The wind rider.
how a wind or a hail rider on a policy.
Okay.
How is if I'm selling this to a building owner and he talks to his insurance agent, the insurance agent says, whoa,
Oh,
don't do that.
okay.
We don't insure that.
Okay.
It's gonna make it a tougher sell.
Right.
I'm just trying to get an idea. if
Yeah.
y'all have encountered that or
we-
had any feedback yet.
There's many of the big theater chains, because we do so many of the national account stuff. I don't want to get too specific here, but we're the largest supplier for national accounts, like the Walmarts, Targets. Everyone who needs to control their costs, and they're using it, and not one of them has mentioned anything about the insurance. So when we see them, I'm going to ask
Ask
them,
Yeah.
because
them, but they are large enough to be self-insured.
the school districts that have them haven't mentioned that to us either. So
Right.
good question. And
Yeah, it's a good question.
be sure and give me your email, and I'll get an answer and see what they say.
Yeah. Yep.
So for a new construction, you said the unit has to be solar ready, or what was that?
Correct. If you wanna power your rooftop, you do need to order it as a solar ready unit, and it's an option. It's just like selecting.
When you go to replace your rooftop unit, or if it's a new building, you order them solar ready.
Now, you have the option of not putting it on the rooftop, you can put it on a separate panel, if you will, and not have to worry about retrofitting.
You can string the string from the rooftop unit. You can string from the rooftop unit to the nearest panel. We recommend that you not go over 200 feet. But that's a pretty good area for you to go.
Oh,
I'm curious as to whether or not you have enough space to fit enough photovoltaic panels on the rooftop to power a 3-ton unit. For instance, this room, I'm going to guess, is 120 by 150 feet to about
Right.
18,000 square feet.
right.
So I'm guesstimating it would use probably 2 3-ton rooftop units, and each one of those panels generates 190 watts.
Right.
Right, so 13 amps for each one of those rooftop units times 208 volts, 3-phase, would be about 4.6 kilowatts. So if I have it figured out correctly, that'd be about 25 panels for each unit. And those panels are about 15 square feet. So 2 3-ton rooftop units, it would only require about 750 square feet of panels. It strikes me that if this were an office building, you could put 2 3-ton units up there and enough solar panels on that rooftop to power those 3-ton units without consuming any outside electricity. Does that sound ballpark?
Right.
Our
Yeah, we do.
3-ton unit takes 2,900 watts to operate full load.
20, okay, 20, so then you certainly have enough room to put.
Yeah, it takes
Correct.
about less than 14 panels to net zero a 3-ton unit.
So you could put one of these on your rooftop, and if, we had a hurricane and the power was out for several days, you can't?
No, it's a inverter system.
No, the
Yeah.
inverter shut down when the power's off is a safety factor.
Right.
It's a good thought, though.
Or if you have what if your generator's on?
If it's generator, then it will. If you're feeding the generator to the packaged rooftop unit, yes, it will.
Because for entities like the county, or school system, the energy consumption in a building from the HVAC system makes up 30 to 40% of the total electricity consumption.
Right.
And I'm guesstimating that if you had these solar powered during your peak hours of consumption, when you could reduce your peak demand, you could lower your energy rate from the utility.
Absolutely.
30, 40%.
But only your power company can calculate your cost reduction on your demand charge. That's not something that anybody can calculate, because everybody's demand charge is different.
Good. You had a question? You had a question? Oh, okay. Yeah.
First question is, what is the communication protocol that it uses for the software?
Oh, the for the website, for the monitoring website, you actually have to buy the communication module, which is basically the device that captures all the data from the microinverter. So for example, for let's say a single phase system unit, we call it Envoy. It's an Envoy communication module that you just plug to any outlet, and it will sense the output of the microinverter.
Is it proprietary?
It is. No, it's outside of it. Yeah, it's not.
Follow-up question to that is, you know, an existing HVAC unit already has a energy management system, and all the infrastructure is already in place. So, I'm thinking that if it was Lawn Works or BACnet or IP based, then you would be able to tie your existing communication system to that unit so that you can save on the infrastructure of the cable.
When you order your rooftop unit solar ready, you can ask for a certified BACnet card or LAN card factory installed in the unit. Or if you're using a DDC controller, take it off your old unit, put it on the new unit, it ties right in. Because we are not a controls company. We tie into whatever system you have. It's automatically set up.
But the efficiency of the panel, you're getting a readout from the efficiency of the panel on a particular protocol.
No.
No,
So
it's
we're looking at
totally
it.
separate.
Yeah.
It's a wire, it's a wireless type.
It's a wireless, okay, so that's
Yeah,
TCP/IP then?
yeah.
Yeah.
Okay, that's the protocol.
Okay.
Any other questions? I see everyone talking, so I imagine there must be some type of question.
Yeah, go ahead.
What's the lifespan, since that microinverter has been on the market just for a short period of time, is that correct? Is that the technology that's been on the market for a short period of time?
Well, it has been out there since the 2000s, but it just lately that became popular or adopted by a lot of the, the
Do you know what the
integrators.
longevity of that unit is?
Oh yeah, well, we do have at least a 5. I don't remember. Is it 5-year guarantee on the microinverter? I think it's at least 5 years for the microinverter.
We have to replace it, how much would it cost to replace it?
A microinverter is around $100 to $200 bucks. Mm-hmm. But I'll tell you, I mean, in California, they've installed thousands of these, and they haven't had a recall or anything like that, and they haven't had the necessity of using the warranty at all.
What's the website of the company?
You can go to this website in Lennox, they have several, but if you go to www.lennoxcommercial.com and you click on solar products, it will take you to an area that will show you a solar calculator so you can plug in where you are. Okay, they want you to know what website to get information. www.lennoxcommercial.com.
Do you want us to do the assessment or not?
Click on solar products,
Do you want us to do it?
and then off to the
We
right,
have the
the
assessment.
upper right, you'll see an e-learning. And that takes you step by step by step how the system works. There'll also be a solar calculator that you can plug in on a map where you are, and you can see what happens to the efficiency of your units by changing the number of solar panels from 6 to 21. So you can sit there and play with it all day long to see what it does for you.
Yeah.
And I will tell you, the further north you are, the quicker it is to be net zero. Down here, we all use a lot of energy because of our temperatures. So in this part of the country, the savings are not as great as they are up north, which is just the opposite of what you would think. But it's because of the time of usage or kind of usage, because we're always in electric mode and usually in cooling.
Any other questions? No. Well, if you have more questions, you can reach either Donna or myself, and we can give you a business card with our emails, just in case if you have more specific questions regarding the components.
Donna, how many did you say these can power a 3-ton unit?
If we do the 235, you'll have to do the math, okay?
Okay.
A 3-ton unit takes 2,900 watts.
Okay.
If we use the panels that are 235 watts, how many panels does it take?
About 12.
12 panels.
About 12.
Okay.